Good afternoon. Yes, Danny, I was able to get those messages. Thank you. And as always, I don't naman check attendance for other sync sessions. But yeah, thank you anyway for letting me know. And as always, expect the recording of this session to be up by the end of the week or latest start of next week. Okay. Um, Before we start, any feedback about the problem set? How was it? It's hard, sir. Hoo-hoo. Welcome to college. Okay. But I can promise you that nothing naman here covers something that I haven't. I mean, that you don't have the skill sets yet for. Because even with your fundamentals, you can figure it out. Kasi you already have all the skill sets needed to answer all of these problems. Except for the last one. That's why I had to remove the last part. Because it involved calculus pala. Sorry, I didn't pick the right problem. So for the last part, I put na the sticky part there. Because I forget you don't have calculus yet. Or maybe you do, but I don't want to put calculus into this course. Okay, wait lang, wait lang. I'm just preparing my iPad screen so we can share your. Okay. Anyone else think it was difficult or challenging or sakto lang? It's such a lovely, lively crowd today. Okay, let us begin by sharing my screen. Ay, nako. Yes. Sige. Kita na ba yung iPad screen?
Yes, sir.
Okay, good. So, nasa problem set 2 tayo. Let's just double check. Section H. Yep. Okay. So, what will happen is I'll just, we'll go over each of the items and kung sino yung gumawa or if anyone wants to either present the work or work through the item. So, kung mari feel mo na, sir, kailangan ko ata ng tulong sa question na to dahil I personally had a hard time with it, then now's your time. You can raise your hand, say, sir, I want to work through this problem with you so you can help me through it. I'd be more than happy to guide you through how to answer this question. Okay? Or kung ikaw naman, you feeling your oats, you're very confident and proud of your solution, then you can raise your hand, sir, I want to show to my classmates how to answer this problem here. Okay ba? Can I expect that from you guys? So anyone who needs help can volunteer to answer the problem with me. And then someone who wants to present what they did, and rightfully so, if you're proud of your work, I will also let you do that. And obviously, if something's a problem or something's exceptionally good, I point that out. That's fee for feedback talaga. So that's the point of these problem solving sessions. It's not because I'm just giving away answers, but it's really the learning process. No? Sharing answers, sharing techniques, and being guided by me, your instructor, through these items. So let's start off with some very basic stoichiometry. No? Problem one gives us an example of a real life scenario that or should happen or should have happened if you were taking this course in real life, no? So diba in real life, this is a lab and lec combination course. It really isn't supposed to be a separate instructor for lab, separate instructor for lec. It would have been sometimes we do lessons, sometimes we do experiments, and everything comes together. So unfortunately, dahil sa online classes, hindi siya ganun ka-integrated. Um, so problem one gives you a taste for what the process of standardization is all about. So standardization is basically trying to get or confirm the concentration or standardize the concentration of something that we'll be using in the lab. And to standardize something means we have to measure it against a standard. A standard is typically a chemical that is very pure and certified to have a certain level of to have a certain concentration or a certain level of purity. In this example, you're share or you're given a primary standard, meaning like one of the highest level of standards talagang ito yung ginagamit sa analytical chemistry called potassium hydrogen phthalate or KHP. So guys, hindi siya potassium hydrogen and phosphorus ha. Ang potassium hydrogen phthalate ay KHC8H4O4. So malaki yung kanyang formula. Now, potassium hydrogen phthalate is a primary standard acid. So it can undergo an acid-base or neutralization reaction. So in our case, we're going to standardize an unknown concentration of sodium hydroxide solution. So meron tayong known potassium hydrogen phthalate. We don't know the concentration of sodium hydroxide. Okay? And the product will be a salt and water. So you're given this kwento of this analysis. There's a sample with a known amount of primary standard taken to be very, very pure, 0.5893 grams of KHP. We put it in a flask, we dissolve it with some water para lang hindi siya solid, and then we will titrate it with our sodium hydroxide. It's typically, it's the sodium hydroxide concentration that we know, and that we will titrate the acid like a vinegar to know how much acid is in our vinegar. I think you'll do that in your lab, diba? In your lab kit. But in this typical example, to know the concentration of the sodium hydroxide, we need to have a standard. Okay? So yun yung KHP. Typically, after we standardize the sodium hydroxide using KHP, we will then use the standardized sodium hydroxide to then analyze unknown acids like vinegar. So yun yung typical experiment talaga nangyayari. So this problem here is just the first half of an experiment. It's just finding or standardizing our sodium hydroxide solution. Okay? So the first question is, how many moles of KHP did we put in our flask? Okay, medyo malabo yung solution, so I'll just trace it out. Can you know work to, by the way? So we write the given mass of KHP 0.5893 grams. Okay. And then oops, ayun sumulat. Ayun. And then we use the molar mass of KHP. So the molar mass you can solve for naman, diba, using that long formula of KH something. C8, tama ba? Okay, tama. C8H4O4. Okay, so you add all of that, tama to. It's around 204 grams per mole. Okay. There's an issue here though. Can anyone tell me what's wrong here?
The sig fig, sir.
No, the sig fig's
Ah.
fine. Grams dito. Dito na yung mole, wala na to.
Okay.
Okay. Wala na yan. Grams per mole na siya. Okay? So, nagkano lang na over lang sa units. Okay, so let's get the blue. And yes, time for sig fig. So this is the proper formula to get moles from mass. And then, okay, sig figs. Ilang sig fig to? 4. And then sig figs na molar mass.
5, sir.
5 sig fig. Typically guys, ang molar mass, ginagamit nating atomic mass sa periodic table, yung periodic tables na may dalawang decimal place. And remember, atomic masses are also measurements. So sig figs count when adding atomic masses. And kapag addition or subtraction, ano ang dapat rule ng sig fig? Least sig fig or least decimal places?
Least decimal places.
Decimal place. So ingat lang. Okay, so a standard periodic table will have 2 decimal places for all the atomic masses. So typical molecular masses for our course will also just have 2 decimal places. Okay? So 5 sig fig, 4 sig fig, final answer tama, 4 sig fig. Lahat ba nakasagot ng parehong 0.002886 moles of KHP? Kaya? Okay. Can I get a thumbs up kung kaya? So I can move forward. Okay, great. The next problem is, ano yung kanyang equivalent number of moles na reactan? Okay? Isa talaga ako. So, balik tayo sa chemical reaction. 1 KHP per 1 NaOH. So, pupunta tayo dyan. So, alam natin na react natin lahat ng KHP. So, we start off with all of the KHP that we reacted with. Yun tayo eh. Yan. And then we use this conversion factor, the stoichiometric ratio. 1 mole of NaOH per 1 mole of KHP. So we can cancel out mole of KHP. So 1:1, same number of moles lang si NaOH. Okay? And then how do we get the concentration and molarity of our NaOH? So we know, ganito karaming moles of NaOH yung napasok sa flask to react with the KHP. And we know that that number of moles belongs to this volume in ml. And molarity is just moles per liter. So yung last thing na kailangan gawin is convert into liters, yung 22.49 ml. And then to get the molarity, tama yan. You have your moles divided by the number of liters. Proper sig fig dapat, 4 na sig fig, 4 na sig fig, so 4 na sig fig, ganyan final answer. Okay? Lahat ba nakasunod? Did everyone follow? Number 1, very easy. Okay. Now, dito, sino yung masumunod? Si Jude, are you here? Wala. Okay. The last question, the last part of number 1 is just about a little bit of theory, no? Bakit hindi importante na we know, na malaman natin kung gaano karaming tubig natin dinosolve yung KHP? Why isn't it not important to know how much water we use to dissolve our KHP? And it says here, sabi ni, I guess ni Jude, I think it does not matter. The moles of KHP were neutralized by the equivalent moles of NaOH. The number of moles depends on the mass of the compound. The delivered mass is responsible for knowing the moles present of the solution, not the volume of water. The volume of water cannot change the total number of moles of KHP. That's true. Okay? So importante dito sa chemical reaction is the stoichiometry between the number of moles of this and this. It wasn't the concentration. So stoichiometry deals with numbers of moles. Yes, okay? At its very core. And so concentration, you can do stoichiometry with concentration, but it ultimately boils down to moles. So even if I dilute the whole reaction with some water or concentrate it, the number of moles that will react between KHP and sodium hydroxide will remain the same. Okay? Now, it does not say that concentration does not matter. Alam naman natin, 'di ba, that other things can change. So, potassium hydrogen phthalate and NaOH will have the same stoichiometry of reacting no matter how dilute or concentrated the KHP is. But what is affected by concentration? So if the before and after is exactly the same, what could be different? Can anyone tell me
The
what
rate of
could be
reaction,
different?
sir.
Exactly. So maybe the KHP and the sodium hydroxide would react a little slower if it were very dilute compared to if it were dissolved in less water. So yun lang yung difference, guys. Rate is affected by concentration, but stoichiometry is ultimately just moles and moles. Okay? Later on, we'll also learn that other things are affected by changing concentration, even if we keep the moles the same. Pero at least tayo, stoichiometry lang, yung before and after, wala tayong paki sa concentration masyado. Okay? So yan. Problem 2 is again stoichiometry, pero ito medyo intense stoichiometry to. So meron tayong, so problem 1 was a volumetric analysis, aka a titration. Ngayon, dito tayo ngayon sa gravimetric analysis. So wala na tayo sa volumes, lahat mass measurements lang. And in this analysis, this is called the combustion analysis. Okay? We will take an unknown compound X, and we know that it contains carbon, hydrogen, and oxygen in its formula, in its molecular makeup. But we don't know ano yung formula niya. Ilang carbon atoms, ilang hydrogen, ilang oxygen. Okay? So our goal is to identify the formula of our unknown. So this is a qualitative analysis. So what we did, we took rather 1.000 grams of our unknown and we combust it, meaning we put it in a reactor with plenty of heat and plenty of oxygen. So C A H B O X, whatever, basta may numbers yan, or N, M, and X. We add an excess amount of oxygen. So super daming pa-pump na oxygen. Initin natin siya. We're gonna burn it. And when things combust or when things burn, they produce carbon dioxide and water. So parehong greenhouse gases yan. Diba? That's literally what powers the world is combustion. Where do all of the carbon atoms go in this chemical reaction? Where do all the carbon atoms go?
So carbon dioxide, sir.
Yeah, lahat sila nagiging carbon dioxide. And then lahat ng hydrogen, ano nangyari sa lahat ng hydrogen atoms natin? Saan sila napadpad?
So water, sir.
Sa water lang. Okay? Now, yung oxygen ng compound natin, malalaman ba natin kung saan yung oxygen ng compound natin? Malalaman ko ba na this particular red oxygens are this one or this one? Hindi, di ba? Kasi marami tayong ilalagay na external oxygen. So, in a combustion analysis, we measure the amount of carbon dioxide we produce and water we produce. And we can only tell the amount of carbon and hydrogen in a compound. Yung oxygen, malalaman natin only by process of elimination. Okay? So ito yung buong process ng process of elimination ay siya yung kung paano nakalist yung mga questions ng item na to. So gagawin natin, the first question is, how many equivalent moles of carbon was captured by the carbon dioxide absorber? So meron tayong reaction. Meron akong reaction chamber and then meron specific absorbers. Okay? So one absorber gets CO2, one absorber gets H2O. Before the reaction, meron siyang mass, habang para siyang filter. So habang yung filter malinis, meron siyang mass. And then ito filter the CO2, bibigat siya. So the change in mass in the CO2 absorber tells us how much CO2 was absorbed. So yun. According to these calculations, whoever did this, he or she or they said that 1.50 grams of CO2 was absorbed or created by our reaction. So how do we get from grams CO2 to moles carbon? As with any stoichiometric measurement, lahat kailangan dumaan sa moles. So kung meron tayong grams CO2, first step palagi ay convert to moles CO2. And once we have the mole CO2, we should know now how much carbon we have. Okay, so note, in 1 mole of CO2, gaano karami ang each element meron? So CO2 means 1 part carbon, 2 parts oxygen. So in 1 mole carbon dioxide, dapat meron tayong 1 mole of carbon and 2 moles of oxygen. Clear sa lahat tong relationship? If I have 1 mole of carbon, I see carbon dioxide, I have 1 mole of carbon, 2 moles of oxygen. If I have 1 molecule of carbon, I have 1 atom carbon, 2 atoms oxygen. So proportional lang siya. Bakit siya importante? Kasi siya ngayon yung next conversion factor natin dito. So now that we have from grams CO2, naging moles carbon dioxide. Yung moles carbon dioxide, pwede ngayon ma-cancel out para maging mole carbon. Okay? 3 sig fig, 4 sig fig. How about 1 mole carbon, 1 mole CO2? Does this conversion factor have any sig fig?
No, sir.
No, di ba? So infinite sig fig or doesn't count. So tama tong 3 sig fig. 0.0341 moles carbon. Lahat ba nakasunod kung paano to nakuha? Okay. So letter B. Can anyone explain B and C? Anyone raise their hands? Okay, letter B is pretty easy. Ano yung equivalent mass ng moles ng carbon na to? And then C and D pareho lang pero for hydrogen. Any volunteers? Sige, Jeremy, would you care to help or guide me through this?
Hello, sir.
Yes po.
Um,
So letter B tayo.
okay, sir.
What is the equivalent mass of carbon captured? Ay, tama. So, anyari dito sa letter B?
From what I've observed, sir, they used the molar mass for carbon, and
So,
basing on the answer from letter A, which is the amount of moles for carbon, they multiplied that to the molar mass of carbon to know the equivalent mass of what was absorbed by
exactly.
the thing.
Okay, by the absorber. Yeah.
Yes, sir.
So, meron tayong 0.409 grams ng carbon atoms na inabsorb. Okay? So, babalikan natin yan. Jeremy, how about letter C? How did they solve for the equivalent number of moles of hydrogen atoms that was captured by the water absorber?
I think it's a similar process to letter A, sir, but this time
Yeah.
using the molar mass for water for H2O, the
So,
equivalent.
so the captured mass of water was 0.41 and then
Yes, sir. And then it is divided by the molar mass for water.
okay.
The grams
that's
of
this
water
one.
is cancelled out, and then the difference
Okay.
is in H2O, there are 2 moles of water instead of just 1. So instead of just multiplying by 1, we multiply it by 2 because there are 2 moles of hydrogen. Because we're looking at how much hydrogen is being absorbed. So
Exactly.
multiply it by 2 and we get this answer 0.045 moles of hydrogen absorbed by the absorber.
Now, in terms of significant figures, does this calculation do it correctly?
To I think the least number of sig figs here is 2, sir. If I'm not
So tama ba tong 0.045?
sumobra, sir, I think.
Bakit? Ilang sig fig ba tong
Wait.
0.045?
Because it's, I think tatlo yan, sir. Is it 3? I want to refresh my memory, sir.
Hala. Guys, dapat second nature ng sig fig by now. I took the liberty of doing extra time with that. Sige. Ano guys, tama ba to? Thumbs up for yes, heart for no. Tama ba to?
Tama pala, sir.
Sure ka? Bakit si Rafael mind blown? Hindi, nasabog na daw yung brain niya. Sige, tama yan guys. 2 sig figs. This 0 does not count. It's just 4 and 5. Okay? So tama yan. 0.045.
Okay, sir.
Okay. And then, just like before, convert it into mass of hydrogen. Again, please standard. That's keeping standard 2 decimal place smaller masses. So, imbes na, pwede naman tong 1.008, ganyan din. Ito yung mass ng hydrogen. Could have this been the same with 1.01. Okay? Now, bakit natin kinuha yung mass ng carbon and mass ng hydrogen? Remember, sinabi natin that we find the oxygen by process of elimination. So yung 1 gram natin ng sample, 1.00 gram CnHMOX. Alam natin na yung mass na to ay combination of the masses of all the atoms of carbon, mass of carbon, plus mass of hydrogen, plus mass of oxygen. And right now, we know the mass of carbon to be 0.409 grams. Right now, we know the mass of hydrogen to be 0.045 grams. O di ba by process of elimination or difference, malalaman na natin si mass ng oxygen. Di ba? So yun yung next slide. I guess work. Okay. So exactly, you take 1 gram of the CHO compound. We remove the C, we remove the H, and you end up with the mass of oxygen. And letter F is just to convert this mass of oxygen to the number of moles. So same lang din. Mass to moles is just using the appropriate molar mass. So 16 grams per mole ng oxygen. Now we have the number of moles of oxygen. So, ano yung empirical formula ng compound natin? Gagawin natin is we will make a compound CHO. CO ay 0.0341. Ano si C? 0.0341 din and 0.045. Okay? So yan yung ating tentative formula. But as with all formulas, kailangan lahat whole numbers. So yung task natin ngayon ay i-transform tong mga numbers into whole numbers. Ano yung trick dito? Ano yung trick para matanggal tong weird decimal numbers? Any idea?
If I recall something from the modules, sir, I think they used the smallest amount and divided every
Exactly.
other amount with that
Exactly.
smallest amount.
Exactly. So we will divide everything by the 0.0341. And this will transform it now into C1 H1.3301. O yan, dito. Yan siya. Okay? Sa solution ni, no, I guess kay Jude or whoever, Yan siya. 1 is to 1.33 is to 1. We can further ease this up or make this um, easy to work with by converting everything to the appropriate fraction. So C1, H is 4/3, O1. Okay? And when you have those fractions, siya na yung nearest fraction. Paano na ngayon ayusin yan? How do we make everything whole numbers?
Multiply 3 to all.
By 3 to all. So I guess the least common multiple or whatever, GCF. I don't know, just do your math. Just simplify the fraction, whatever's. Okay, so this becomes C3H4O3. This is our empirical formula. An empirical formula is like the simplified formula of a molecule. So let's pretend we have hydrogen peroxide. Guys, ano ang formula ng hydrogen peroxide? Alam niyo ba?
Is it H2O2, sir?
H2O2. This is hydrogen peroxide. Ang empirical formula ng hydrogen peroxide is actually just HO. Kasi 1 is to 1 lang yung proportion ng H and O. Pero, so empirical formulas are not the accurate representation of a molecule's makeup. Okay? It just gives you the proportions of everything, but not necessarily the true number of atoms it takes to make that compound or that molecule. So right now we have an idea of the structure of our compound, but we don't know the true nature of it yet, the true formula. So paano yun? So right now we have an empirical formula with an empirical mass. This is around 88 grams per mole. So around 88.0 something. Okay? Paano natin ngayon malalaman yung molecular mass? So the molecular formula rather. So we know that we have the molar mass of the actual compound to be 170. So this is a given. Typically, a chemist who does combustion analysis will have to do another experiment. So they will do a mass spectrometry or they will do some other thing para malaman nila yung molecular mass. Okay? Baka magta-titration ka rin or something. Basta double, this is just half the story. So your lab partner did the other half of the experiment and nalaman nila na yung actual molar mass ng compound 176. So we have molar mass divided by empirical mass. 176 divided by 88. This is 2. Anong ibig sabihin yan? That the actual molecule is 2 times the size of our empirical formula. Okay? So yung factor na to will be the ratio or the factor that we have to multiply to our empirical formula to get the molecular formula. And so our molecular formula should be C6H8O6. Okay? Tama. 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 Okay? So yan. So far, so good lahat ng answers. Lahat ba nakasunod? Ilan na lang tayo dito. Sige, guys. Okay, confident? Sige. Sino? Danny, are you here?
Yes, sir.
Yan, Danny, work mo to, no?
Yes, sir.
Sige, can you go ahead and give me a short break so you by explaining naman your work here. Okay, kwento ko lang muna yung problem. This is not analytical chemistry. This is purely demonstrative chemistry. This is just Gen Chem solving. There's a reaction between zinc metal and hydrochloric acid. This reaction produces zinc 2 chloride or ZnCl2 and hydrogen gas. In order for us to know how much hydrogen gas we made, we put a balloon at the top of the flask just to capture whatever gas we produce. Okay? We took 3 flasks and we filled them all with 0.100 moles of HCl. So alam natin yung moles, hindi mo na kailangan alam yung volume na yan. But in each of 3 different flasks, we added differing amounts of zinc, 1.31, 3.27, and 7 grams of zinc. You're tasked with eventually telling me which flask contains which sets of reagents. Okay? Now, the first question is, how many moles of zinc does it take to fully consume the 0.1 grams, or sorry, 0.1 moles of HCl? So, paano mo siya ginawa, Danny?
First, sir, I use the 0.100 moles of HCl. Then I multiplied it to the conversion factor of zinc to HCl. So 1 mole of zinc over 2 moles of HCl. Then the answer is 0.0500 moles of zinc. So we need 0.0500 moles of zinc to completely react with 0.100 moles of HCl.
Tama. To consume all HCl. Sig figs. Tama ba to, guys? Let's ask Ira, ilang sig figs tong 0.100 moles HCl?
Um, 3, sir.
And how about the 1 mole zinc to 2 moles HCl? Ilang sig fig yan?
Infinity.
Tama. So our final answer should have 3 sig fig. Is this 3 sig fig?
Yes, sir.
Okay, it is. Okay, tama to. Now, let's go on now to each of the flasks. You're asked with comparing the amount of zinc we actually put to the amount of zinc that was needed to consume all HCl. So go ahead, Danny, the floor is yours.
So first, I named flask A, flask B, flask C, since we don't know what's flask 1, flask 2, and flask 3. So flask A, I used 1.31 grams of zinc. Then I converted it to moles. So multiplied it to the conversion factor, 1 mole of zinc over 65.38 grams of zinc. And I got 0.0200 moles of zinc. So the 0.0200 moles of zinc is less than the needed 0.0500 moles of zinc. So 1.31 grams of zinc is a limiting reagent.
Tama. Okay, how about flask 2?
The next, I used 3.27 grams of zinc, multiplied it to 1 mole of zinc over 65.38 grams of zinc, to get 0.0500 moles of zinc. So it is exactly what we needed. So the reaction is stoichiometric, not a limit. I
Stoichiometric, yeah.
know, no limiting, no excess.
Tama.
And
So
then
guys, ang stoichiometric, a reaction in stoichiometric amounts, this is like a unicorn, ha? This is, we can put it on paper and it looks real, that everything is sakto, but again, sabi ko, in reality, things are never perfect. Palaging merong isang excess, palaging merong isang limiting. Even if it's just by a few micro or nanograms, meron at merong yang difference. Okay? Pero this is a pero yun, in this case, we'll take it as stoichiometric. So, kunwari yan, this is just paper anyway. Then the last scenario, we'll go ahead, Danny.
Then the last would be the 7 grams of zinc, again converted to moles of zinc. So 1 mole zinc over 65.38 grams of zinc is equal to 0.107 moles of zinc. It is more than what we need. So the 7.00 grams of zinc is an excess reactant.
Okay. So, sa flask A, sino fully consumed?
C zinc, sir.
HCl is excess. Okay? Dito, Zn and HCl fully consumed. Kasi nga stoichiometric. And then the last one,
HCl fully consumed, sir. Zinc excess.
zinc excess. Okay? Oh. Sa storya pa lang na yan, sa analysis pa lang natin sa letter B, sino kaya dito yung pwede nating identify na flask? So in the first flask, kita nyo yan, after the reaction, meron pang natirang solid sa ilalim na zinc metal. So obviously, this one is the zinc excess, diba? And HCl is the limiting reactant. Clear sa lahat? Clear sa lahat kung bakit tong flask pwede natin i-label kaagad? So sino si zinc excess? HCl na ano? C flask C. So this is our C ni Danny. Okay? Now, the second flask and the third flask, so the one in the middle and the one on the right, they both don't have any leftover zinc. And the only difference they have visually is the size of their balloon, which means it's the amount of hydrogen gas that they produce. So paano natin sila malala? How do we then find out how much hydrogen gas is produced? How much of whatever is in excess and all that jazz? Whoa! Okay. Para malaman natin yung amounts of each chemical that we produce, include especially the gas, we need to use our rice tables. Okay? This is the best. Even actually from the very start, if we used our rice tables, we would have actually gotten all the information we needed to answer all these questions. But sige. So tama. Let's go to this first rice table. Flask 1. Tama ba to? Oh, this is C pala. With the HCl as limiting. So ito yung flask na marami yung zinc. Okay? So we had initial, everything in moles. We solve for this. This is a given. So HCl is the limiting reactant. Yung change dapat lahat ng HCl magagamit. And then we solve for the equivalent amount of zinc that gets used up, which we did also a while ago na. Clear ba sa lahat tong mga changes dito sa table? Kung saan sila nagaling? Wala na. Hello?
Sir, yes,
Nawala
sir.
ba ako?
No, sir.
Hindi, parang nag-freeze. Okay. Sige. So we do that. We have to solve again based on the limiting reactant kung ano yung dami ng products na magagawa. So yun yung nangyari dito. Kay H2, meron tayong 0.100 mole HCl, and then we use the conversion factor 2 HCl is to 1H to get the number of moles of H+. So ito yung number of moles of H+. Okay? Let's go to another flask. So this is flask 3 is the what we labeled A. So original work ni Danny. We calculated we only had 0.02 moles of zinc, again same HCl. We know that zinc is the limiting, so si zinc yung i-fully consume natin. Yung amount of HCl na makukonsume, okay, depende kay zinc, so minus 0.02 zinc, pero with the conversion factor ni HCl. Dalawang HCl per isang zinc. So 0.04 ang makukonsume na HCl. And then the amount of H2 product that gets created also depends on the zinc. So plus O2 moles of zinc, 1:1 lang yung kanilang factor. So plus O2 moles of H2. So final, nagamit lahat ng zinc. Meron tayong excess na 0.06 moles of HCl, and we create a theoretical yield of 0.02 moles H2. And kay flask B, you can do exactly the same. Lahat sila 0, 0, 0 lalabas, no? And you will also solve the 0.05 yung kanyang yield ng H2. So flask B should yield 0.05 moles H2. Flask A and flask C, oh sorry, 0.200 and flask B 0.0500 mole H2. So balikan natin yung balloons. Alam natin ito yung may excess zinc. And therefore, ito dapat si flask C. Tama? So ito na yon. How about A and B? How do we differentiate them? Based on the expected yield of hydrogen gas. So sino dapat ang mas maraming gas na hydrogen?
Si B, sir.
Si B. Ito si stoichiometric. And then this is A that only has the zinc as the limiting reactant, producing only around 0.0200 moles H2. 0.0500 moles H2. 0.0500 moles H2. So yan. Clear sa lahat by process of, by the deduction and elimination, no? Yeah, deduction is elimination. So yung logic behind determining which flask is which. Kaya? So like I said, tong part na to purely theoretical tong problem. This is not a typical chemical analysis that we do. This is like a for fun kind of item. Okay? Pero yun. Now, speaking of real analysis, ito yon. Ito yung ginagawa talaga ng mga analytical chemists. Okay? So number 4 is very tricky. And I'm not quite convinced with the numbers I see anywhere. So I guess for a treat, I will go over all of the questions using my work. Kasi medyo, hindi ako convinced sa work na ginawa niyo. And that's okay. Okay, that's okay. So let me go ahead and share my Excel. Ikwento ko na lang. Okay. So, wait lang po. Okay, ayan. Kita na ba yung Excel, guys?
Yes, sir.
Okay. Sige. Let me go ahead and enable annotation. Now, ang given sa item was that a chemist, okay, is describing or trying to study the chemical decomposition of dinitrogen pentoxide into NO2 and O2. And I think nakita ko naman yung chemical reaction na sinulat. Tama naman balanced naman siya. No? So this is the balanced equation. Question lang. This is balanced kasi dapat same number of atoms on both sides. So question for everyone here in the chat. Ilan ang nitrogen atoms on both sides of the equation?
4, sir.
4. How about oxygen? Ilan ang oxygen atoms on both sides of the equation?
10, sir.
10. Everyone else aside from Danny, na mental math nyo na ba? Na 4 nitrogens and 10 oxygens
Yes, sir.
on both sides? Kaya? Okay, good. So we can move past balancing equations. Okay. So here comes the tricky part. We are given data. So the scientists took a certain amount of this, they put it in a flask, no? They sealed it off, and then it will decompose over time, over a few thousand seconds. And they take the initial concentration of N2O5, and then every certain time interval, they took a measurement of its concentration. Maybe through spectroscopy or something, through a technique, okay, through an analytical method. Nakuha nila tong data na to. Your first task daw is to plot N2O5 against time. So the concentration of N2O5 against time. You should end up with something that looks like this. Okay? Itong graph na to. Sa unang tingin pa lang, guys, what can you say about the graph? Anong nangyayari kay N2O5?
Nako-consume, sir.
Nako-consume, so bumababa yung kanyang concentration. Ano pa? What can you say about the rate of consumption? So it's consumption, so it's negative. Pero ano pa? Is the rate constant? Is the rate changing?
Changing, sir.
Changing, sir.
So what can we rule out immediately? Can this be a zero-order reaction?
No, sir.
No, di ba? So hindi siya straight line na pababa. So medyo mahirap na ngayon siya kasi curved. So paano ngayon pag curved, sir? How do I solve for the concentrations of everything else? Okay. The assumption here is that our reaction is a sealed container, meaning the volume, it remains constant. In our case, we can imagine the volume as 1 liter. Bakit gusto i-assume na 1 liter? Kasi ano ba ang molarity? Molarity is just moles per liter. So ang pwede mong gawin is pag in-assume mo na 1 liter yung solution, ito ay number of moles na rin. Gets? Yung first assumption,
Yes,
that this
sir.
reaction is, it's already constant volume. So the concentration can directly become moles easily. Okay? So anong ginawa ko? Initial, meron tayong N2O5, wala tayong NO2, wala tayong O2. Okay? So tanggalin ko muna tong mga to. So para lang pakita ko yung process. Okay. Ang ginawa ko dito, okay, is that I got the difference between the initial amount of N2O5 and the current amount of N2O5. Ba't ko ginawa yon? Ano yung ibig sabihin nitong C6 minus C7? Ano yung meaning nitong difference?
Is it the change, sir, in
Bakit ko gusto malaman yung change in moles of N2O5? Ano ba nangyari? Ano ba nangyari kay N2O5 na nawala dito?
nag-yield?
So,
React.
kung balikan nyo yung experiment natin dati, kaya gusto ko talagang na-transfer yung marble from bowl to bowl. Imagine nyo, ito yung tinatanggal natin na marble kay bowl A para ilipat kay bowl B and C na products bowl. Gets?
Yes, sir.
Yes, sir. Yung
Oo, siya yung kinukuha nating marami na para ilipat-lipat natin. So to yon. This tells us how many marbles did we get out of bowl A. Okay? Now, so this will give us the moles of N2O5 that we consume from 0 to times 600. Ano naman tong times 4 divided by 2?
Is it the ratio, sir? The
This
molar
is the
ratio.
molar ratio. So ano to? Remember, I'm solving for the concentration of NO2. There is 4 moles of NO2 per 2 moles of
oxygen.
N2O5
N2O5.
205.
reactant. So, Excel stoichiometry siya. Kita? Does everyone see how? This is solving for the amount of NO2 created for this specific change from time 0 to time 600. Okay? So, obviously, bawal ka magkaroon ng unit sa Excel, no? Formula ng lahat to. Tanggalin ko ulit yung mga moles na yan and formula. So, yan. Now, ba't ko nilagyan to ng dollar sign? So, parang ginagawa ko siyang fixed reference cell. Kasi, pag hindi ko ginawa yan, okay, so, at nag-drag and drop ako dito, anong mangyayari? So, lumiliit yung concentration ng product na fina-form. Does this make sense? Like, I think I saw one graph in your in your table do this. Hindi, di ba?
Hindi, sir.
Dapat tumalaki yung concentration ni NO2 kasi product na ginagawa. So, anong mali nito? These are just giving you how many moles of were made between the two time frames. Ang gusto natin malaman is the cumulative amount of moles created. So, kailangan yung initial cell, palagi kailangan si initial. Yan. So, to, kailangan yung kanyang initial state, ganun pa rin sa start. So, ba't ko ilalagay yung dollar sign? Para kapag drag and drop ko siya, the C6 remains the same throughout. Gets? So if I click any one of these, pansin nyo, the blue cell is still C6. It's still the initial concentration of N2O5. Okay, so adding that dollar sign holds one in place. And then dragging it, it means the red cell will also follow going down. Okay, so yan. Next. Sir, paano ka gagawin yung O2? Pwede ka magpakahirap at gawin yung ganong process ulit. Or, remember that stoichiometry applies also for the ratio of products. So remember, for every 4 NO2 that you make, you also just make 1 oxygen or 1 O2. So yun yung ginawa ko dito. I took advantage of that. Now this is D7 gives you moles NO2. And we know that there is 1 mole O2 for every 4 moles NO2. Kita?
Yes, sir.
So stoichiometry lang siya between products. Okay? Kita ba lahat? Kung paano kung yung meaning ng formula doon kay O2?
Yes, sir.
No? Oo, now, so yan, tanggalin ko lang ulit lahat yan. And then, this time, wala tayong reference cell, drag nyo lang yan pababa. And yan na ngayon ang concentrations ni O2. So what you do now is you will put them all in their own plots. So kung gumawa kayo ng 3 separate plots, sir, how do I transfer one plot to the other? You can actually copy one and then paste them into another. And then lalabas sila. At magsasama-sama sila lahat. Okay? So if you have 3 separate plots, you can actually put them all together by pasting them into the graph. Or if you know how to properly plot everything, you can do it like highlight everything and then insert. You can choose a scatter plot na connected. Tapos yan siya. Okay? Tapos kung kailangan lagyan nyo yun ng x-axis label, y-axis label, and title. And you can even be super OC like me with the grid lines and stuff para maganda tignan yung graph. Okay. Ako wala pang title, so minus points ako. Joke, hindi. So ito na yung itsura ng graph of all concentrations. Okay? So una sa lahat, balikan natin yung reaction formula. So it is 2N2O5 becomes 4NO2 and O2. Sa itsura pa lang nung graph, who has the steepest slopes? And based on the stoichiometry, who has the quickest rates?
Si NO2, sir.
The rate of creating NO2 is the fastest. Diba the orange graph? Kasi sa formula or sorry, sa reaction equation, siya yung may pinakamataas na coefficient. Siya rin yung pinakamabilis. How about kay oxygen? What can you say about its graph? Dahil siya yung may pinakamaliit na coefficient, ano siya graphically?
Or flat.
Siya yung pinaka-flat na slope, di ba? Halos yung nag-change masyado. Okay? So, yun. Question. How do we relate the slopes of the three graphs at any point in time? Ano yung relationship ng mga slope or rates ng reactions nila? At any point in time, how do I relate all three of these slopes? Ano ang kanilang relative rate expression? So the rate of N2O5 is delta over delta time. The rate delta NO2 delta time. And how does that relate to delta O2 over delta time? Ano yung kanilang ratios or coefficients to equalize them? Ano yung factors ng relative rate expression? IRA or
For the, I'm not sure, sir, but for the N2O5, it's 1/2.
pero si N2O5 kasi nako-consume. So paano natin siya gagawing positive rate?
Negative.
Tama. Negative 1/2. And then how about the two positive rates? Ano yung kanilang equalizing factors?
For the NO2, positive 1/4. And then
And for
the
oxygen,
O2, positive 1/1.
tama. So paano natin to i-interpret? Okay. How much faster is NO2 being created compared to N2O5 or compared to O2 being created? Paano to gagamitin? Paano natin gagamitin tong relative rate expression? How do we use this? How much faster is this rate compared to this or compared to that O2? Anong gagawin natin when comparing rates? Danny, merong formula for relative rates. There's a formula in our lecture last week.
Thank you,
Ay,
sir.
sorry. Oo. Nandun siya, di ba? For any chemical reaction, it really is the reciprocal of their coefficients. And then for the reactants, it's negative para lang opposite natin yung negative slope. Kasi 'di ba negative ang slope ng mga reactant. So nilalagyan natin ng -1 na dagdag. So ano yung paano natin i-relate ang rates ngayon ng isang reference rate to everyone else? So how much faster or slower is NO2 compared to O2? Para ma-compare, kailangan matanggal tong factor na to. So paano ko tatanggalin yung rate, yung factor ni NO2? What do I do with the whole
Multiply
equation?
4.
Multiply by 4.
Multiply the whole equation by 4. So ano mangyayari? Magiging 4/4 to. Mawawala siya. Okay? And then to, magiging -4/2. Ito magiging 4/1. So sinasabi natin that the NO2 reaction or creating NO2 is 4 times faster than O2 being created. Kasi nga mabagal si O2, di ba? Very flat graph. And it is 4/2, which is just
2
2 times faster
faster.
than consuming N2O5. Kita? O sige, balikan natin yung factors ulit. Okay. So again, -1/2, 1/4, 1/1. How do we compare the rate of N2O5 to everyone? Anong gagawin ko ngayon? Kung gusto kong gawing reference of comparison, ang rate ni N2O5.
Multiply the whole equation by 2, sir.
Multiply the whole equation by 2. Okay? So, paano natin i-interpret to? The rate of consuming N2O5 is
1/2.
1/2 the speed of NO2's rate. And it is
Twice.
2 times faster than oxygen. So, pansin niyo siya. Let's go back to the graph. Ang rate ni N2O5, itong blue, it's only twice as steep or to half the steepness of this orange graph, which is very steep, but it is 2 times steeper than this flat O2 graph. Kita nyo? Ganun gamitin yung relative rate expression. Okay? Sige. Now, let me go back to the problem set questions. So, yun ang A, B, C, and D. So write the balanced equation, check. Plot everything, check. What is the relative rate expression? Check, we've solved that. And how does your graph show the relative rate expression? Check. Kita nyo na lahat graphically, gets nyo na, di ba? Yung relative steepness ng graphs. Okay, the last two questions, E and F, is about finding the most linear integrated rate law. And then, what is the differential rate law expression for this reaction? And then, what is the constant K based on the linear regression, including proper units? So, ngayon, integrated rate law, diba? You're measuring concentration of a reactant against time. Kapag linear yung concentration of reactant against time, alam natin dapat zero order yon. And then ano pa yung gagawin natin? Another column, we will create ln of concentration of a reactant against time. So you get ln of that, then you drag it down, and then ganon. And then dito, for another test, diba, for second order, we will get 1 over concentration against time. So we take 1 divided by the cell C6, where our concentration of N2O2 is. We will drag it down to everything, and then boom. For all the values of N2O5 concentration, meron tayong 1 over concentration. You will create 3 separate plots. Okay? So, nilagyan ko lang kasi ng line to, pero dapat walang line yan. Okay, so sa green, I see concentration lang. Si blue, si Ln, and orange is 1 over. Okay. Notice I labeled my x and y axes, and I also included the equation of the line. With that, okay, with these 3 graphs, anong order si N2O5? Or ano muna dito yung pinaka-linear na graph?
CN205 po, sir. CLN. N205.
Yung seconds, yung blue.
Si second, the blue graph, right? With Ln.
Yes, sir.
Paano nyo masabi na siya yung pinaka-linear?
Yung R squared value niya, sir, nearest to 1.
Yes.
Tama. So, I saw some graphs here. They included the equation of the line, but no one input their R squared values. So, big boo-boo yun. So, please make sure in your midterms, you will do this. I'm telling you now pa lang, kasama tong gantong graphing and N2O5 and concentration over time. I'm telling you guys, kailangan nyo, gagawin nyo talaga to sa midterm ninyo. Okay? Yan, ang makuha ninyo. You'll get 3 lines and you have to compare R squared values. Para masabi nyo, okay, ito yung pinaka-linear na relationship. And therefore, anong conclusion natin? Dahil ito yung pinaka-linear.
First order siya, sir.
So yung rate natin ay K times N2O5 raised to what order? 1. So tama, sabi ni Danny, first order reactant to. So yan yung ating differential rate law. Okay? Differential rate law is yung rate equals K times concentrations. Si integrated rate law yung medyo mapangit na tingnan na math equation, which is this thing here. So Ln N2O5 equals negative K. X is our T. Plus Ln N2O5 initial. Okay? So ito naman yung second equation sa baba. Yan yung ating integrated rate law for a first order reaction. So itong y equals mx plus b, yan yun. Okay? So dahil dyan, ano ang value ng k? Ano ang reaction constant k natin dito? Saan siya nakukuha sa graph?
Yung slope, sir.
Slope. Slope lang ba or dapat yung negative ng slope?
Negative ng
Siya yung
slope, sir.
negative ng slope. Tama. So, k equals 0.0005. Okay? Now, sir, paano po yung units? Paano yung units ng K? So, balik tayo sa rate law, differential rate law. Alam natin that rate is molarity per second equals K. Hindi natin alam. And then we know that N2O5 in square brackets means molarity. Diba? Molarity raised to the 1, that's just molarity. So ano dapat unit ni K? Molarity per second equals molarity times what? Ano units ni K dito?
Molarity per second times
O divide both sides by molarity, di ba?
times molarity to the power of -1, sir.
So divide both sides by molarity. So 1 over S equals K. O di yan ang unit ni K, 1 over S. Or, simply put,
S to the power of -1.
yan si K. Okay? Nakasunod ba lahat? Kaya? Okay. Now, balikan ko yung problem set. Okay. Pero yung po naman dito. Okay. Yes. Okay. So sana lang mas clear yung problems, answers ng iba. So, last problem, more reaction rates. This time, okay, we have a generic reaction between A and B. So the equation is 2A plus B becomes A2B. And to determine the differential rate law of this chemical reaction, basically to know the orders of each of the reactants, A and B, okay, we came up with 3 experiments. So in experiment 1, we gave A and B the same concentration of 0.1 molar. We got a certain chemical rate for the initial rate of the reaction. Experiment 2, what did we do? We kept B constant, but what did we do to A? We doubled it to 0.2. Okay? For experiment 3, we kept A constant, pero si B naman yung dinoble to 0.2. Diba? Now, ano yung point ng design ng experiment na to? Remember that the order of reactant that tells us how the reaction rate will change depending on concentration. Diba? So, kunwari, meron akong zero order reactant, kapag denoble ko yung concentration, ano dapat mangyayari sa rate? Mag-change ba dapat yung rate? Does a zero order reactant change the rate of a reaction?
No, sir.
No, it doesn't. So, dapat constant. So, pag dinoble ko si A, kapag yung rate pareho pa rin, zero order si A. Okay? Now, kapag first order si A, anong mangyayari kapag dinoble ko si A?
Is it double din, sir?
Double.
Double lang din, 'di ba? Si first order ay direct or direct
Directly
proportionality.
proportional.
So linearly proportional. So pag dinoble ko yung concentration, double lang din si rate. And then kapag si A ay second order, ano dapat? Pag dinoble ko yung concentration ni A, ano dapat mangyayari kay rate? Ang second order ay relationship ay squared. So gaano kabilis yung reaction dapat?
Times 4, sir.
Times 4. Pag hindi kayo sure, and like I said, in reality, minsan may order na 1.5, may order na 2/3, pero rare yun, rare. For our course, 0, 1, or 2 lang tayo. How do we systematically solve for the order of reagent given this data? Ito yung nakikita ko dito. Tama. You do that by comparing differential rate laws. So, ginawa dito, rate 2, diba? Rate equals K, A to the M, B to the N. And then rate 1 is the same thing, K, A to the M, B to the N. Pero yung concentrations ni A and B is nakadepende kung ano yung experiment na sinusundan natin. Diba? Kung yung mga 0.1 or 0.2 ba. So, ginawa niya dito, kinompare ang speed ni rate experiment 2 ni rate kay experiment 1. So, plug in rates. Okay. And then, mapapansin nyo dito na even if we don't know the value of k, maka-cancel out. Even if we don't know the value kung ano yung order ni b to the n, 0.1 to the n is equal to 0.1 to the n. So, pwede rin silang ma-cancel out. Okay? So, yung ratio nito is just the ratio of 0.2 and 0.1 raised to the m. And 4 is just 2 raised to the m. And even if you don't show me the logarithm part, you can already put the next line here is m equals 2. Okay? That's perfectly acceptable already to my, as long as you show me this part, that's already the complete solution there. Okay? So to super systematic, even I wouldn't do this. Pero, okay, yeah, m equals 2. So ano yung sabihin yan? Rate, alam natin ngayon is sum k, a raised to the 2. Ngayon si b raised to the n. Si b ngayon yung unknown. So para malaman natin kung ano yung power ni b, compare naman natin si 1 kay experiment 3. So ginawa niya dito, yan. Compare rate 3 to rate 1. Same thing here. Plug in the rates. Cancel out 0.1 to the m, 0.1 to the m, which is why now know it's 2, no? K cancels out. So you have 2 equals 2 raised to the n. And even with just that, simple na to, n equals 1. Okay? Ganun kasimple. Obvious na kasi to eh. 2 is 2 raised to the 1. And therefore, n is 1. And ito yung ating final differential rate law. Differential rate law is rate equals k a squared b to the first power. Next question, what is the overall rate order or reaction order? Paano isolve ang reaction order?
Sir, I just added po the exponent of A and B to get the overall
Tama.
order of reaction po.
Exactly. So, yun. O nga pala to, yellow. Sa'yo pala tong yellow. Okay. Thanks, Krisan. So, 2 and 1. Overall order equals 2 plus 1 equals 3. Okay. Last, what is the rate constant with proper units? Paano natin isa-solve yung rate constant? All you need to do is to plug in one experiment's data. Yun lang. So I guess si Kristen yung gumawa nito, no? Rate is ka squared b to the first power. So ginamit niya, I think, is experiment 1 data. Tama, si 0.00143 equals k times 0.1 squared times 0.1. K is 1.43. Tanong, ano ang units dapat ni K? So kalahati pa lang to ng sagot. Gagawin natin to systematically, guys. Ano ang units ng rate? Molarity, diba?
first.
R equals K a squared b to the 1. So si K, ano ang units ni a squared? Molarity squared, diba? And then anong b to the first power?
M.
Molarity. So m per s equals k m to the third power. Oh. So ano gagawin natin? Divide both sides by
M
m to
cubed.
the third power, diba? So k equals
1
1
over
over
S M squared.
m squared s, or k is 1.43 m to the negative 2 s to the negative 1. Kaya, nakasunod ba sa paano kunin yung units ni k? Okay. So, bilis tayo nakatapos niyan. In-explain ko na lahat eh. Wala na. Wala nag-participate. Saya. That's a read on you guys if you're all dense, just so you know. That's an epic burn from your teacher. Please, at least yung trabaho nandito. Sige, pagbigyan ko na kayo. Pero next time guys, let's step up. Pero at least okay naman yung trabaho. Okay. May questions? May tanong? Kaya na ba? Yung tanong eh, kaya nyo na ba gawin to on your own? Sige, if you have no other questions, feel free to leave. If you do, I'll stay behind to entertain anything last minute. Sige. Maraming salamat and sana next time. Kailangan nyo ng coffee, kailangan nyo ng Red Bull.
Beer daw, sir, sabi ni Dan.
Pwede naman din beer. Sige, gusto nyo Jose Cuervo pa. Shots tayo. Sige lang. Jaeger bomb, wala na. Forever ka nagising. Class shots. Sige, Raf, libre mo. Mahal ang alak ngayon eh. Papa-grab. Sige, I'll stop recording na. Kwento-kwento na lang tayo.